Our next speaker is Marvin from Kubermatic, and he's going to talk about KCP. And it's an interesting technology because I think if you think about the next 10 years and you ask yourself what is the missing piece of where Kubernetes can go. I mean, the core of Kubernetes, obviously we have OTel and all other kinds of ecosystems around Kubernetes or working on Kubernetes. It's this technology. It's bringing Kubernetes to everything, everywhere. Thank you. Marvin.
Thank you, Vaser. You're giving me the much better title for the talk, which would have been like everything everywhere all at once. I can't change it anymore. But yeah, and thank you for the invitation to be here. So I want to talk about KCP. I want to talk about API control planes. And we're going to jump right in. Just quickly, my name is Marvin. I am a team lead at Kubermatic. I am also a maintainer for KCP. That's the obvious interest why I'm here to show you what we're building. So, agenda. First of all, I want to set the stage. I want to talk a bit about context. I want to talk about Kubernetes as an API layer, because I will tell you in a minute, forget about containers. And we're going to talk about why. Vasu did the nice thing for me, and he already explained hosted control planes. So, but I want to talk about what people have been building to address some of the problems that you could see when you focus specifically on Kubernetes as an API layer. I also want to then talk about what KCP really is. Like, why are we here in the first place? Why am I here? What am I going to show you? Then a few of the core concepts in KCP that are additions to what Kubernetes itself is already doing, and how these hopefully are useful to people solving specific problems. And then I want to talk about what KCP unlocks, and I like to call that the API marketplace. So basically, I want to be able to show to you that KCP can enable you to share services through APIs in a, very, I'm not sure if fancy is the right word, but basically start this marketplace of offering and of consuming services through APIs. And then we're going to wrap up. And I'm just going to check the time. Okay. All right. So first of all, I just mentioned Kubernetes is an API layer. And I want to tell you something here. Forget about containers. Not because container orchestration isn't great, and that is Kubernetes' role, but in this specific context, so in my role here, I don't care about containers. Because I want to talk about APIs. I want to talk about enabling higher-level services and sharing these with parts of your organization. And that is basically a stark difference to offering compute. So Kubernetes in itself is basically offering you compute, right? It's containers, it's running your applications. But actually, the API layer of Kubernetes is very, very interesting because it's extendable, it's heavily standardized, and the tooling around it is already pretty great. And, we're just 10 years in, so let's see what comes after that. Basically, the Kubernetes API can be broken down to this. So a resource in the Kubernetes API has different parts, and they basically give you a very extended way of accessing different APIs and different resources in that. So all APIs in Kubernetes are automatically grouped. These API groups also have versions. Resources can be namespace, so they can be further logically isolated from each other. And resources then have a specific resource type. And you can also request resources by name. But the idea here is basically this is a very, very solid API. And honestly, why build this yourself? If you already have this, why not go with what Kubernetes offers you? Because all of these have already done that. So basically, Kubernetes is easy to extend. We've all probably installed CRDs already to run some kind of controller or operator. And extending this Kubernetes API, so basically this here is like, well, not stupidly simple, but it's very simple. Instead of writing code to, basically integrate a new endpoint into your, I don't know, your Go or your Java or your Rust or whatever API framework, you just define what your API looks like. You can extend Kubernetes without a single line of code, but you actually need to then reconcile the APIs, but just defining API endpoints, you just submit a YAML file, and that's basically it. And all of these projects have basically done that, and they are, I think, a huge testament to the success of extending the Kubernetes API with higher level services. Most of these are, well, more on the container orchestration side. So a couple of examples, so Rook or kubedb, they are more on the side of, well, they're going to create containers in a specific way. So in a way, they extend the orchestration framework of Kubernetes in a way that containers get created in a specific way. So that is still more or less Kubernetes. But then you have projects here that don't create containers at all. You have Crossplane, you have Caverno, and they basically create a new kind of service for you. Mostly Crossplane, because Caverno is kind of like a meta thing for interacting with the Kubernetes API. But Crossplane gives you orchestration over something completely different. So there are no containers involved. Well, I don't know, maybe, but mostly Crossplane orchestrates not containers, but other types of resources. And they basically went and, well, created a very comprehensive ecosystem just on top of the Kubernetes API. And that is the value that the Kubernetes API brings us. It's not necessarily the container orchestration part, although of course that is what most people use these days and what, well, drives the community at the moment. But the Kubernetes API can be so much more. And it's pretty awesome. So basically, this is what KCP took as a learning from Kubernetes, from the Kubernetes ecosystem. The API that was created to orchestrate containers and then was made to extend, so you can basically integrate extended orchestration patterns. It suddenly turned out to be something, I think, that's not something completely else, but it's basically a very, very nice thing that we can take and basically put it in another place. Because, and we heard a little bit about that in the previous talk, Kubernetes clusters are, I wrote local here, and we saw that in some of the slides that there are many Kubernetes clusters, clusters around the globe in different regions and different cloud providers. Kubernetes isn't really meant to be scaled across regions. Mostly all the, let's say, the CCM, so the cloud controller managers, they don't expect that. Running Kubernetes clusters stretched across cloud providers is generally a bad idea. So Kubernetes clusters are meant, to orchestrate containers in a specific region. And some of you might have, seen this already in your career. Kubernetes clusters can also get pretty crowded as soon as someone wants to install certain controllers or operators, because some resources like CRDs, they are cluster scoped, so everyone shares them. So that means if one team wants to use a specific version of this operator and then there's another team that says no, but we want this version of the operator, well, suddenly you need to give them 2 Kubernetes clusters because you can't put them on the same cluster because, well, the CRDs won't mix and match unless the operator has done a lot of diligence and created different API versions, but even then it gets dicey. So basically, I don't want the container orchestration part of Kubernetes because that's not my focus, and Kubernetes clusters can get crowded. And now basically I'm going to talk about hosted control planes, which you already heard about. So this is one of the, I would say, solutions to the problem of, maybe a single Kubernetes cluster isn't enough. And we've heard about this in much greater detail than is on my slides. And this is a really good pattern because it gives you strong isolation. You want teams to basically have their own, place to work in. You want to isolate them from each other, you want to give them their own Kubernetes clusters, and this is a great pattern for that. But in many organizations, you actually might want to have people break down these barriers. So then suddenly you start to say, okay, there's one team in my organization, they provide a specific service, like they have the database team or so, and then they have their Kubernetes cluster, and then you have consumers across your organization, they have their Kubernetes clusters, and in this model they're isolated from each other. So how do you get the databases to these teams, or how do you even get access to requesting a database to these teams? Do you give them access to your Kubernetes cluster? What do? Well, what if we virtualized API servers? So what if we didn't spin up a new fully functional control plane each time a new team or a new, sub-organization appears that wants to have an API or a Kubernetes cluster? What if we instead did this? So basically, what KCP introduces as an idea is the idea of logical clusters. So instead of spinning up a fully functional Kubernetes control plane every time someone wants to have a control plane for the APIs, you create a logical cluster, and these logical clusters share the same data store, and they have isolation in place. So the airbag, for example, in these logical clusters, they are different. The APIs available in these logical clusters are different, and this basically solves the issue with the CDs that we talked about earlier. And they still share the same data store. So this, assuming that you can, scale this adequately, is a much cheaper way, because instead of waiting for, new containers to start, for my etcd to start, for my API server to start, I basically just carve out a new small place for the team on the same data store. And this is basically what KCP is. So this idea of logical clusters is, I would say, at the core of it. So if you want to provide Kubernetes-style APIs, then KCP is the horizontally scalable control plane for exactly that. So if you want to provide high-level services, then you go ahead and you create workspaces in KCP. And I should have explained workspaces. Sorry, I meant logical clusters. We're going to come to workspaces in a bit. But basically, KCP is exactly that. KCP took the ideas from Kubernetes and said, we're going to take this and we're going to take some of the code that Kubernetes uses for the API server, and we're creating an own project with a different focus. Because Kubernetes focuses on containers. KCP focuses on APIs. And that is the huge difference here. So, KCP is actually a CNCF project since the end of 2023. We are part of the CNCF Sandbox, which is really great as an opportunity for the project to develop in a vendor-neutral environment. And we should talk about workspaces, because I name-dropped them because, I don't know, some of the vocabulary that you work with just gets ingrained into your brain. But actually, workspaces are this implementation of logical clusters. So logical clusters as an idea are basically implemented by workspaces in KCP. So workspaces are a unit of isolation in KCP, and you can basically, more or less think about it as, a higher order of namespaces. So namespaces give you some way to basically organize your resources, and workspaces sit above that. So workspace has multiple namespaces. And the interesting bit about workspaces is, as we talked about earlier in logical clusters, is that they have their own API resource types. So every workspace basically has different APIs available. And this is basically where you can isolate teams from each other to the degree that you want them to be isolated. And teams can install their own APIs. They can consume the APIs that they need. They're no longer bound by, a cluster-wide, which CDs can we install? Can we install this CID? No, I actually don't know. Maybe the other team already has installed that, because they needed this operator in this version. You suddenly end up with, I have a workspace, I own it as a team, and I can completely self-service myself, and I can basically say, okay, I just want a specific API, I just want this specific one, and I don't care what the other teams are doing. And obviously, same as with namespaces, API objects in a workspace are only visible in that workspace. So the same name in a different workspace, it doesn't care, they are resources in a different workspace, so they are separated from each other. Yeah, and because workspaces are logical clusters, they are cheap. So this is basically the point that I was making earlier. Workspaces don't spin up individual control planes, but they feel like one, because they are their own Kubernetes API endpoints. And yet, they are there within seconds. In comparison to even if you do hosted control planes very efficiently, that's probably still a couple of minutes. And they cost you memory, they cost you storage, they cost you CPU. Workspaces all do this in a very minimal fashion because they don't spin up any new workloads. Let's take a look at this from a little bit more practical standpoint. So, workspaces can also be stacked into each other. So basically, you start with a root workspace. A KCP installation always has that, and you create workspaces within that root workspace. So this is kind of a file system that you suddenly have, where you create folders where you can basically place your files or, well, your Kubernetes resources, and can organize them by that. And you can see on the slide that every workspace has its own Kubernetes API endpoint. So each of these URLs actually are functional Kubernetes APIs from a client perspective that you can feed into your client of choice, mostly kubectl, I guess. And this allows you to talk to different workspaces as if they were different Kubernetes clusters. And because it feels like a file system, you can also navigate like a file system. So basically there is a small kubectl plugin from the KCP project, and this, well, allows you to navigate. So you start out in the root workspace, you start it like in your root folder, and you basically go down into your file hierarchy, or in this case, your workspace hierarchy. So basically in each workspace, you can see the workspaces that are the child workspaces, because workspaces are just another API object that you create to create a new workspace. Then you switch into that, and this way you basically go all the way down. So in the end, I ended up in a workspace team A that is nested into an org A workspace, which is itself nested in a root workspace. Okay, now these are some of the primitives that KCP adds, and this basically allows for much better logical separation of teams, because suddenly teams become independent, they have their own APIs, and this means that within a KCP installation, within this tree that we saw earlier, suddenly you can create a marketplace, because you can offer APIs that parts of this tree can consume. And this is basically what I'm going to walk us through here. So service teams, so teams that offer databases, that offer storage, that offer higher level services. You could look at the AWS console and find a lot of services that a service team could provide. They want to provide these services. They need to expose them, but that's not really, what they are focused on. So why have them create their own API servers or API control planes? Why make them, okay, you need to write your own API, you need to maintain it, you need to document it. Why not use the Kubernetes API for that? So let's think about being a service team. So let's say I have something to offer. That could be a database. It could be a certificate signed by the company, a certificate authority. It could be pizzas, if you happen to be the pizza service within the company. But basically, I want to provide something. I have a service to offer. So what I do in KCP is I create something called an API export. The API export is basically my offer to others in KCP. Hey, I have something to offer. I have a service. I have an API that I want you to use. And I don't want to go into much detail with the YAML here, but essentially you define resource schemas that your API offers. And these are more or less CRDs. So if you already have a CRD, because you have some tooling around that, you have them defined in your code and you generate CRDs, you can easily convert them to resource schemas. What is the difference to CRDs then? CRDs have basically two aspects. One aspect is they define your API schema, they define how your resources look like, but creating them also registers the API, makes it available in the Kubernetes clusters. But these are two distinct things. The schema and the registration, they are two things. And API exports and API resource schemas in KCP decouple that. So resource schemas just define the schema of my resources, as the name says, but they don't get registered. So this is the difference. An API export is just the offer of an API. It doesn't register to any of the workspaces. Before we get into how to consume APIs, I would like to talk a bit about the technical details behind providing a service, because for now I've just defined my API as a service provider. Well, because KCP is so Kubernetes-like, you just write a controller. You might already be able to easily transform your existing Kubernetes controllers to a KCP-aware controller, because it's not that much of a difference. And KCP has a special concept called virtual workspaces. And you could see virtual workspaces as kind of computed views. So a controller that you write for your service talks to an API export, and that API export gives you a filtered view of all the resources for your API. So suddenly you don't end up going so you don't go into individual workspaces where each team has the resources and you would need to basically fetch them and come back. You talk to virtual workspace as your central authority, where you get all the data from that you need as someone implementing a controller. And in specific, this applies to the API export virtual workspaces. So KCP has different types of virtual workspaces, and you can also easily create your own. So a virtual workspace, there's a framework within KCP to build your own views on the data in KCP. But in specific, for a service provider, the API export virtual workspace is interesting because you get a view of all the resources just for your service. So we can see here as a kind of little illustration that as a service provider, I see all the different pizzas that someone has ordered. So it doesn't matter if it's the org A team or it's the org B team, you see all of them, so you can reconcile all of them. So in combination with implementing patterns to horizontally scale your controllers, you suddenly end up with, okay, I can provide a specific service for my whole organization. And this is just a summary of how you basically convert a Kubernetes controller to a KCP-aware controller. Depends, of course, on your controller, but basically you have a couple of steps, a couple of things that you need to adjust, and your Kubernetes controller is ready to be a KCP-aware controller. That's basically it. We maintain a fork of controller runtime, which adds these additional features that then you would use to create a KCP-aware controller, but it's rather simple, to be honest. Now, this is the service provider side. So this is basically where I provide a service, and I define how I want to provide it, and I implement how I provide it. And now we're getting to the part where the consumer comes into play, because offering a pizza service is nice, but if there's no one who wants pizzas or who orders pizzas, then why did I get a pizza oven in the first place? So within each workspace, and we're going to basically dive a little bit into the semantics of workspaces. In each workspace, because I said earlier, okay, workspace URL is a fully functional Kubernetes API from the outside, or Kubernetes-like API. That means that you have a specific endpoint to discover all the resources in a Kubernetes API. So kubectl works here. So kubectl's API discovery basically tells me, okay, there are a couple of resources in my workspace. KCP provides a couple of the core resources, so config maps and secrets. They are there. Missing are, for example, pods, because we don't want to provide pods to users because, well, we provide APIs, we don't provide pods, we don't provide container orchestration. So creating a pod in KCP would basically do nothing. But there are more resources in here than the core API. The workspaces that I talked earlier about, they are here as a resource. So, and this is why I said, okay, you can create a workspace within a workspace as a Kubernetes API object, and you get a child workspace out of that. And you can see that they are here, they are in a specific API group, and actually they are here because they are a bound API. So KCP itself implements this pattern that we're right now going through. Because in each workspace you have, by default, depending on what kind of workspace you created, you have these API bindings. And API bindings are basically the missing part from the two steps that I explained earlier with CRDs. So the API export defines my API, and the API binding, it binds the API, so it makes it available in a workspace. And this is the part where, well, the separation happens because the API binding can exist in a different workspace. So the team that wants to consume a specific service, it sits in a different part of the workspace tree, and it references the API export that is, in this case here, in this example, coming from KCP itself, from the root workspace. So even within KCP, you're always a consumer of a service offered by KCP itself. This is basically where you start. And this enables exactly this. So there are teams in your organization, they are in different parts of the workspace tree, and you start out with team A being a consumer team because, for example, they provide a specific business application, so they mostly care about, okay, I need a database, I need an object storage, maybe I need some kind of, I don't know, function as a service, you name it basically. And team A, which is the consumer in this part, binds the API. It creates API bindings to the APIs offered by the database team and by the object storage team. And well, then team A has these resources available, can create them in their workspace, and the other teams actually can't access these workspaces except for being fed the resources that team A created in their APIs. So the database team will never see anything else coming out of team A than databases, even though they ordered like 10 object storage or something. But this creates a nice level of isolation while allowing teams to consume from different parties, from different service teams all across their organization. And of course, this has, this goes back to what I said earlier, where hosted control planes give you strong isolation between the different Kubernetes clusters. And now we are breaking down these isolations within the context of KCP on purpose. We make these things, well, have holes. So one team can talk to another team. And in a hosted control plane setting, this wouldn't be as easy. And of course, this needs to be secured. So KCP extends the Kubernetes airbag model, mostly with a couple of custom verbs and sub-resources. So basically, giving a specific team access to my service is as easy as giving it the use verb on my API export. So I, as a service provider, in my workspace, I can decide who is capable of consuming my API. by creating an API binding, even though I will never see the API binding resources, and I don't have any control about them with Airbag. But this binding, this process of using an API export, of binding it, even though I don't see the API binding resource, I can control the creation of an API binding. I can control if the API binding that is created is allowed to use a specific API export. All right, and I'm a little bit quick on time, but let's wrap up. So, I think, I'm not sure if this is a controversial statement, but APIs are eating the world. Some companies have started with this, like, I don't know, a couple of decades ago. I think AWS, for example, they started out with everything needs to be an API. All our services need to be provided with an API. And I would say that's part of why they were so successful. And it's not going to get less. We're going to have more services. We're going to have more companies, more niche experts interacting with each other. So why not provide services via APIs? And why not use something that is already, well, in IT world, I guess 10 years are a long time. But why don't use Kubernetes concepts? Because they have matured over time, and they have proven to be very effective at providing services that go beyond container orchestration. We call the slide that I had with the different names. So yeah, let's use technology we know and create open service markets. Because what we've seen here, why stop at that? Why have KCP? So basically, when you have KCP, the idea to further connect everyone is obviously in there. So if you have a workspace, you have APIs, why not also consume APIs from other KCP instances? So there's a lot of potential here. And KCP itself is great for single organizations, for offering services to their customers or internal consumers, but KCP can do so much more. And I think that's basically how I would like to end. So KCP is a global control plane for API-driven platforms. It takes all the learnings from Kubernetes as a control plane and applies them to APIs instead. Workspaces allow you to create a very fancy and hopefully pretty accurate view on your organization and give teams the autonomy that they need. And providing APIs through Kubernetes data concept is incredibly easy. And that's basically how I would like to end. It's a community project. If this sounds interesting to you, please talk to me. And I hope there's an amazing future for KCP. Thank you very much.
Indeed. Thank you very much, Marvin. Are there any questions? Oh, I see a lot of hands going up. Okay.
One question for me. Maybe I missed it, but about the logical control planes. Does this sit on top of an existing control plane? Like, can I use it in combination with something like Azure Kubernetes Engine, or does this completely replace the existing control plane?
Well, it's its own separate control plane, but you can easily run it on top of Kubernetes. So you can start KCP as a pod, as a workload in the Kubernetes cluster, and then you talk to KCP directly to consume APIs.
Next question. You're next.
Thanks for the interesting talk. One question, as a service provider, I would need, for example, the credential to actually provide my service. Do I also have access to secrets that are stored in the consumer namespace, or is that a concept that works?
Yeah, that is a possibility. So in your API export, you can define what adjacent resources you need, and then they would also be provided to you through the virtual workspace that is provided for API exports.
Okay, yeah, quite interesting. What
one of the questions that came to my mind is you're sharing the data plane that was on one of your slides. So having a data store or having an API defined is only, well, it just gets us halfway there. We still need a controller. If we want to integrate the operator pattern or something, we still have to have a controller that listens to events and so on and so forth. So if you workspace everything, how do you handle the controller part, which now obviously has to be workspace aware? So only having CRDs, for example, for a certificate, like if we have this certificate controller, it needs to know about workspaces somehow. How did you solve that?
Yeah, so this is basically these couple of slides that I have here. So your controller needs to be workspace aware, yes, that's true. And this is why we have this version of controller runtime that is workspace aware. So,
would I have to, sorry. Me as a I don't know, a potential controller provider for example for certificates, I would have to still recompile everything, and I can't just make my controller aware of that, if I understood that correctly. I have to recompile.
Yeah, if you think about this vendor overarching KCP, when you bind something from the vendor, how would you implement kind of things that follow this, like payment? I mean, you order like a database for EU, but somehow it has to be connected further.
it's a fantastic question. This is part of basically, I think, what the core of KCP currently doesn't consider, like this kind of business aspects, but this is definitely something that I think we need to build in these kind of situations. But yeah, it's a good question. You can probably do some quota calculation or something, because you know the resources that have been created, but right now there's no built-in way to do that.
So I think this is exactly what we have in mind, and I think if you, at this point, still have one KCP API against which you can do this bind, but the moment you want to do it cross-organization, you need to have a kubectl access, and before you have that, before you have the namespace, some type of account, some kind of a secret contract exchange should be, not secret, but the secret for the contract exchange should get it, right? And so that's another layer of, let's say, account bind, account exchange, and so on, which we still have to embed. Right?
And as a simple way to handle this today, basically you don't need to give this permission to bind your API until someone has, signed your contract, or clicked the button. So this would be an easy way today already to say, okay, you haven't given us your payment details yet, you're not getting this hour permission to bind.
So as an idea on top of that, there could also be a billing service, and then as a service provider, you would create in another workspace the billing object to cash out or get the cash.
Yeah, that's the obvious, yeah.
Mighty, you're hired. Okay. Again, thank you very much, Marvin. And thanks for everyone being here. 10 years of Kubernetes. Let's wait for the next 10 years. Or not wait, but let's be active. Thank you, everyone.